fields in Nebraska. So, giving you a very small background, rain-fed agriculture is one of the main agriculture which exists throughout the globe. It actually encompasses 80 to 85% of the total world's agricultural land, because most of the places out on the globe, they don't have enough infrastructure or capital investment to invest in terms of machinery or irrigation scheduling. So most of the agricultural world on the globe is driven by rainfed, by the rainfall or the precipitation. And maize and soybean are the two major field crops in the world, as well as in the whole United States, mid plains, Nebraska, and the other high plain states. So it makes it very essential to have a better understanding of the rainfed yield and yield influencing factors such as precipitation, which is essential for global economic sustainability. So a better understanding of the rainfall connection or the relationship with the yields would actually help us to enhance modeling techniques and allow for more accurate yield forecasting and prediction.
So just let me quickly stop you. So that's right. So you said maize and soybean are two major field crops in the world. Even so, in Nebraska, those two are the primary two. What are the others important crops on the global scale? Rice and wheat. There you go. So keep in mind, rice and wheat is actually probably more important for other countries, developing countries, right? So,
Yes.
Here in the Midwest, U.S., certainly soybean and maize are the largest one. Okay.
Yep, I've shown the images in the one on in the center on the left side is the soybean, and one on the bottom is the corn. And the map on the bottom right side actually shows the distribution of rainfall throughout the state of Nebraska. So I took an irrigation management class with Dr. Daryl Martin. So I just remembered a rule that as you go from west to east, like going from Scottsbluff to Lincoln or Omaha, the precipitation increases by 1 inch every 20 miles. So in Scottsbluff, the annual precipitation is around 16 inches. So as you keep on going east, every 20 miles, the precipitation increases by 1 inch. So the precipitation around the region, like Lincoln and Nebraska on the bottom right side, is around 36 inches. So from 16 to 36 goes like 1 inch up every 20 miles. I mean, just a food for thought. So in the past, crop growth and yield models have been used to predict rain-fed and irrigated grain yields. Just to talk about a few of them, like I've listed some of the crop simulation models which have been studied in the past. Like for maize, we do have a series maize crop simulation model. The image for that is in the upper right-hand corner, where where Jones and Kinery in 1986 developed a model to predict the growth or the yields for the maize plant. That was one of the earliest modeling methods which was done. And for the soybean, we've used crop grow that was used by Jagtap and Jones. It's on the upper left side. And fuzzy logic, if you go on dating it back when it was used to estimate yields through modeling, the first one was done in the year of 1978, and then moving on to artificial neural networks, Dr. Ermak has done it during 2006, and the technique which is used as a part of this paper or this journal, that's adaptive neurofuzzy inference system. It involves the mixture of fuzzy logic and artificial neural networks. We are learning as a part of this class as well. So that was done by these renowned scientists, but they didn't had the same area of field and the same crops. So that's one of the things which makes this paper unique. So water availability throughout the globe is one of the most yield impacting factors, and rain-fed agriculture as I told in the beginning, that it encompasses around 80 to 85% of the global cultivable land. So yeah, that's one of the things which is essential to be studied or modeled. The main strength of this model can actually help us to develop complex relationships between model inputs and output, and it would always give us a better understanding of the effects of dormant season precipitation and the within season precipitation on rainfall yield. So the dormant season is the season which extends when the crop is not in the field. So it goes from the late fall months like September, October, and involves the whole months till the spring, till May, when the crops get planted. And the growing season is the season when the crops are in the field, like from May to September or October. So, as a general, approach for this whole study, the authors, they decided to have a common growing date for the whole state of Nebraska, and that was assumed to be 1st of May. And the harvesting date was also considered to be consistent, and it was considered around 1st of September. So the main area of study for this particular project was Nebraska, and it comprises of 93 counties, and all those counties were considered as a part of the study. And just talking very briefly about the climate which exists in Nebraska, it ranges from arid, semi-arid in the western third of the state to subhumid or humid in the central and eastern part of the state. So from the north, the Rockies, they influence a lot of the weather of Nebraska during the winter months. And during the fall or the summer, the currents from the Gulf of Mexico flow towards north, and they are more influencing during the summer months. And the county average for this specific study for rain-fed maize and soybean was obtained from year 1996 to 2012 using the USDA National Agricultural Statistical Survey, and all these years were accounted as a part of the study, and daily historical data from the weather stations across Nebraska and from the adjoining states like Kansas, South Dakota, Missouri, Wyoming, Colorado, and Iowa were also considered as a part of the study. And there were total 50 weather stations, and the data set was downloaded from AWD and weather station data. So in the end, we're trying to, relate the precipitation with the yields for corn and soybean as a part of this project. So the interpolation was done using a GIS static tool, which is known as ordinary kriging. And in the beginning or in the past, authors have actually studied different interpolation techniques, and they found out that there's no statistical difference between different extrapolation techniques like kriging or IDW or spline interpolation. So they're almost the same, but yeah, as a part of the study, ordinary kriging was considered for extrapolation, and it actually fits a mathematical function to a given set of locations within a specified radius. So the third bullet point is the one which I was talking about. There's no statistical difference existed between all these different interpolation techniques. And in the end, just to take an average precipitation for each month or for each season, zonal statistical tool was used to determine county average precipitation data. So this is something about the statistical tool which was used as a part of this whole study. This is the whole diagram, starting with the inputs on the left-hand side, X and Y. X in terms of this whole study was considered to be the precipitation during the rain-fed, for the rain-fed treatments and throughout the year, and the Y was related to yield. So the model inputs for this study were yield and precipitation. So something a bit more about this ANFIS system is it is a network representation of Sugano type fuzzy inference system endowed with a neural learning capabilities. And it's a feed-forward neural network structure in which each layer is a neuro-fuzzy system component. So The learning capability of this system allows for nonlinear mapping between inputs and outputs at the same time. And the most common learning process used in MFIS are backpropagation and hybrid, which I'll talk in the coming slide. So backpropagation actually uses a form of gradient descent. So it keeps on decreasing, which assumes that error surface slope is always negative, and hence it constantly adjusts the weight towards the minimum, minimizing the error. And hybrid learning process combines backpropagation and the least squares method. I thought someone spoke online, so yeah, sorry. which decreases the dimensions of the search space and usually decreases the convergence time substantially. So this is the map, like of whole thing, which was considered as a part of this whole study. So as a part of the input data was divided into pre-testing years, like 2000, 2005, and 2010, to minimize any potential differences in gradient over time as a result of seed hybrid development. And the initial membership functions were developed using fuzzy C-means clustering from the training data, and an epoch number of 50 was selected randomly based on no further reduction in the training and checking data sets. So the training data was, so the input data was divided into training data, which was like 85% of the whole input data, and the checking data was around 15%. And then after feeding it over there, a few MFIS parameters were selected, just as in the first bullet point, an epoch number of 50. And then MFIS training and check-in were carried out. And when the predictions were okay, and then it was validated, and finally the conclusions were drawn. So the models which were tested to establish a relationship between the precipitation and the yield were as follows, as in the bullet point, the first bullet point. So the first model was considered as yield as a function of precipitation only in the month of May, and so on. Like in the second one, it was precipitation in May and June, and so on till combining all the months together. And then yield was also related to the precipitation in the dormant months, in the months when there was which were not growing, and like the crops were not there in the field, and they were also related to the seasonal, and a function of dormant and seasonal together, and at the end annual precipitation throughout. And these MFIS models were actually evaluated using R square and RMST. Based on the reported R squares and RMSTs, the performance of these different models were evaluated. So as in the table, we have the precipitation for all the months together, pooled together, like just for like one of the growing seasons. So moving on to results, this actually shows the precipitation for the 3 years which were considered as a part of the study, 2000, 2005, and 2010 randomly. And the precipitation distribution shows that in the west part of the state, there was not a lot of precipitation, but yeah, as you start approaching east side, there was a lot of precipitations, and the variations were there while you go from north to south as well, with more precipitation on the south side in comparison to the north side. And the yields were actually greater in the northeast part of Nebraska, and they decreased from east to west following the precipitation gradient. So there's less of precipitation as you go from east to west. So that was the reason that there were lower yields on the west side of the state, and lower rainfed maize and soybean yields occur due to less precipitation compared to central and eastern Nebraska.
Yeah. And can you stop? A couple of things. So 1 inch is how many millimeter? 25.4. Okay, so you want to, so 30 inches roughly 750 millimeter. That's the measurements that you have to keep in mind. Do you have a map of 2012? I wonder what's the distribution look like in 2020.
Unfortunately, we just had 3 years.
2000 is pretty bad. Well, it's certainly showed up there.
You can see that.
Okay, 2000 you're old enough to know.
Yeah.
Well, it certainly showed up there, right? So compared to others, the highest, even in the southeast Nebraska, you got like 400, right? So yellow was 400 to 500, 500 to 20 inch.
Yeah.
So it's pretty, yeah.
Like in terms of all the years, 2010 was considered as a good year, like where they had a lot of rain.
Yeah.
And 2000 was the year they had very little.
Yeah. Okay.
And I think it was done specifically just to study variability, like as a part of the study, where they took like the year where they had minimum precipitation, 2000 maximum, 2010, and on average 2005. So that it could be validated to different scales. So these are the tables where the results from training, checking, and testing data were analyzed, and the top table actually consists of the combined data set from all the 3 years, like 2000, 2005, and 2010. All the data set was pooled, and then 85% of it was used for training and then checking like randomly, and then the following relationships were developed. And it was found out that if you keep on adding more inputs to the model, the R square would increase, that is the confidence on the data set would increase, and similarly the RMST for the model would decrease. So adding more components as a part of the input would give you more confidence when the combined data set was used, as you can see on the top table for both corn and soybean. So like if you see the top table, table 2 for the maize, or the bottommost function where yield is a function of all the months where like during the growing season, it had minimum RMST and almost comparable R square in comparison to the other months. And similarly, the same for soybean. So talking about the table on the bottom side, we had 3 years, 3 different years. They were all put separately, and then they were studied accordingly. And the results were the same. That as you keep on like adding the inputs, then you'll have more confidence on how the model would perform. So during the dry year 2000, 2005 average, and 2010, a very wet year, even the relationship of the yield as a function of precipitation for all the months was pretty high for both maize and soybean.
So Jasmine, why don't we just kind of stop here and then looking at these two tables and think about it?
Yes. Please feel free, share your thoughts.
So these are all rain-fed crops?
Yes, all the
rain-fed soybean?
Rain-fed maize and soybean, yes.
Was there a reason why in 2005 the model kind of falls apart?
I mean, it's just the nature of the model, I guess. I mean, that was one of the major findings of the study. So
what's the model? It's a characteristic of the model itself?
Yes, it's a characteristic of the model itself. So ANFIS was used to, develop a relationship, and that's what they found out.
I think 2005 had pretty almost an even or very little gradient. So
yep. Yes, that makes sense. Yeah, that was included in the summary of this whole journal as well. Yeah, like 2005, it was not very different in different parts of the state. So, and 2010 was the year when they had a lot of difference throughout. And similarly, 2000, it was very dry, but yeah, it was still different. And one more Fascinating thing about this study actually, it will be pretty evident from the graphs, which is in the next slide, that the relationships for maize were really strong in comparison to the relationships developed for soybean because of the fact that maize, the response of maize in under crop stress conditions is much different in comparison to soybean. So soybean doesn't respond like very differently under water stress conditions, but maize is very sensitive. So yeah, the relationships developed for maize were really strong in comparison to soybean.
I'm asking a question
Yeah.
to the North Platte.
Okay.
Let's give them an opportunity to ask questions they may have. That.
Yep.
Kind of interesting to see that maize, the third line, seems to actually be the better predictor.
Oh yeah.
So May, June, and July seem to be the better predictor for maize across the board, even in
Okay,
the
sure. Yep. So the thing. So, like talking very briefly about the physiological response of the maize, there are times when it really needs water, and there are times during the growing season, even if you feed water or like if you put water, it won't make a big difference. So the initial months are the months, when it actually needs a lot of water, specifically during V12 and beginning of tasseling, that is R1 stage, reproductive stage. So yeah, it is during those like months and the initial months that the crop goes through those stages. So that is one of the reasons that like it has a strong relationship during the months of May, June, and July.
So early establishment is important, is what you're saying?
Yep. So early months precipitation is really important in comparison to the later months. But like that's not
probably true for human beings.
But yeah,
I have seen enough evidence of that. Yes, early growth is important.
Yes.
If you didn't start well, then exactly your whole adult life could have been.
Yeah, but like that's not usually what happens during normal growing season. We have a lot of precipitation during the last weeks of July or early August, and that's hardly when we need irrigation. So some of the producers, they plan to plant the crops accordingly.
Yeah.
But like that's not the usual.
Yeah, but you also be once when you look at the data, when you interpret this, you want to be really careful. And it looks like it's easy to fall into the pit that you interpret that as the precipitation beyond July become not important. You know what I'm saying? Right? If that's all you need, May, June, and July, those 3 months give you the highest R square to predict yield. Then does that mean you don't need any rainfall between August and September? You can still have pretty good yield.
Yeah.
Does that indicate that, right? Right. Yeah.
Maybe like a weighted
yeah.
weighting or something.
Like one fascinating thing which I also noticed as a part of this presentation right now is for the bottom graph for the maize response during all the 3 years, like for the 3 months which we are talking, May, June, July, the R square and RMST for the year 2005 is really ideal. I mean, just for the 3 months, if we just talk about and like for the year 2005, the R square and RMST, like for 2005, it's really cool. It's really ideal. So that means that like precipitation during first 3 months, it plays a significant role. About the development like that's what like the modeling conveys us.
Okay. Yeah. All right. So Jerry said, "I don't think so." Yes, it was one. Okay. So Hope asked, "Yes, I was wondering if maybe the model would have responded differently if the precipitation in different months were considered. Yeah, maybe one early month, one late month, Yeah,
Oh, yeah.
That's a good point.
Yep, that's a very good point.
Because you are only testing one set of the sequence, right? Those variables gets into the model.
Exactly.
It could be you walk the other way around. You look at what the elimination, and you find out, you could well drop, the July and June and July, but you included the August, September, and then you would interpret the results completely different.
Yep. I think that's very true. And there are whole different permutations and combinations which could be applied for these growing season months. But I think this paper came as a part of a class taken up by the co-authors, Dan Rudnick and Vasudha Sharma. Vasudha Sharma is assistant professor in Minnesota these days. So yeah. No, it was Vasudha for this paper. Yeah. Yeah. Actually, both of them have their first and the last initial same. So V Sharma and V Sharma.
Yeah, that's the two. Yeah, they're brothers and sisters.
Brother and sister. Yeah. So it's a bit confusing. But yeah, for this it was Vasudha. So took up the course together. So yeah, moving on to the next slide. So this is the relationship for the corn on the left side. I mean graphs. I just used the snipping tool and I pasted them over here with my best judgment, and that's it for the maximum clarity. So on the left side we have corn, and on the right side we do have soybean, and the models as you go from top left to top right and then bottom are for the very first graph it's the yield as a model of the precipitation in May. The right one is May June. If you come on the bottom, like in the center row, the one on the left side is May, June, July. The one on the right side is May, June, July, August, and the bottom is all the months, like till September. So you can see, very clearly while comparing corn, the response of corn and soybean, the relationship of corn is much stronger in comparison to the relationship of soybean, just because of the fact that corn is sensitive under water stress conditions. So the response of yield as a function of precipitation was much stronger for corn. And with higher R square and lower RMSD for the maximum months, that is May extending till September.
Is this a particular year or is this
So this one is a pooled. It's pooled, for the 3 years, 2000, 2005, and 2010.
And 93 counties.
Yep, 93 counties.
Yes, the number of points.
Yes. All of them were combined and then these graphs were established.
Blue are 2000.
So yeah, the blues are the triangles are the 2000.
Yeah.
The square is the 2005, and the dots, the big dots are 2010. But the relationship was established using all these points. Both corn and soybean. And the yield was predicted using ANFIS in megagrams per hectare.
So the message you convey is precipitation water is important for productivity.
Yes.
Right.
So and one more thing is the data set which is considered as a part of this study is was the land which was not irrigated. So it was just rain-fed agriculture. But that's what we were interested in as a part of this study, because around 80 to 85% of the land, agricultural land throughout the globe, it's a rain-fed treatment. So irrigation is just over on 10 to 15% of the agricultural land. So yeah, that was more important as a part of the study. So only Nebraska. So this data set is just for the Nebraska state, including 93 counties. And now, this one, okay. So in addition to the months which were the precipitation months which were considered as a part of the study, The co-authors also felt that including the longitude as a part of modeling would also be very helpful. So they included longitude or longitude, whatever. So yeah, as a part of the modeling input along with the precipitation month to see if the relationship improved or not. Because I think I just told that like as we go from east to west, the precipitation decreases. So that made the whole sense that we should actually check if the longitude would make a difference to the model output or not. And strikingly, it was found out that the performance of the model improved. As it was evident from the reported RMSDs and the R squares. So the confidence on the model increased as we determined longitude for both the pool data set on the top and for all the 3 years, which is on the depicted in the table on the bottom. So feel free to look over and have some thoughts or suggestions, whatever you like.
I do have a thoughts, and this is probably applied to a lot of people doing experiments here. So including a longitude in your model, and you find out it's probably improved the performance, or it's probably significant when you look at the coefficients, right? Mm-hmm. Well, does that mean it has a causal relationship? So that's a very fundamental, research philosophy question. It doesn't, right? So association doesn't mean causal relationship. So you want to make sure that you understand it, right? Had you replicate another, get another data set from another state, including the longitude information model, and I can guarantee there is no association at all in here. It is just because this never started. We got this really strong, influence from the west to the east about that precipitation gradients, and maybe it's all covariates, right? So longitude is also covariates of the precipitation amount in all those mountains.
Yep. Yeah. That's totally right. Yeah.
Yeah. So keep in mind about all this. When you be really careful, particularly when you're trying to make the statement that you actually don't do an experiment, you're doing observational study, and you find your x is significantly correlated with your y. But you can't make the statement that x causes y, right? Because it's just association. So in this case, longitude has probably has something with the yield, but does not directly cause yield to vary. It is the precipitation. But the precipitation correlates with the longitude. Then that you get the second association going on. Make sure that you be really careful in your own study about making those statements. Okay.
Yeah, that's a very good point.
It happens a lot for the natural resource type of study, which is observational. You are not in medical world. It's probably less because you always do very controlling. It's experiment, right? So you control the variations of other unrelated variables.
You're still sick.
Right. And in some of the association, there are underlying association that you don't do, right? Association between age and blood pressure, association between gender and some of the biometrical parameters that you don't know, right? That can. So yeah. Anyway, so that's the you want to make sure that you're well trained as a scientist. That be careful about making your conclusions.
Exactly. That's a small but very important point. I mean, even I kind of had a impression in my mind that it's actually the longitude which is driving the whole thing, but it's not the longitude, but it's a gradient. It's a gradient. Yep. It's true. And the relationship with including longitude as a part of the whole model, in fact, had stronger relationships in comparison to the previous one, where all the data sets from 3 different years were pooled, and then they were modeled, and then predicted yield had a very strong relationship with the actual yield for the model with the maximum inputs, that is on the bottom for corn. And again, corn had stronger relationship in comparison to soybean just because of the fact that corn is more sensitive under water stress conditions.
Corn also produces more biomass.
Yes.
So more biomass. So for pretty much for the plants, it is the ratio of the evaporative transpiration and the carbon assimilation, right?
Yep, that's
So
right.
that ratio is pretty much there's a difference between corn and soybean, but they are comparable.
Mm-hmm.
So the more transpiration means water use that you have, you accumulate more biomass, and that is obvious that that relationship should be stronger for corn.
Yes, yes, very true.
So what is your x-axis? So corn is 0 to 15 mega.
Yes.
So
Yep.
tons per hectare.
Yeah.
And what's your soybean? 0 to 5.
Yeah. It's 0 to 5. Yeah.
So that's the difference in the biomass accumulation capability of corn versus soybean.
Yeah, I think the scale is big. Yeah, in comparison to that. Yep. Okay. I wish the graphs were big. I mean, the tables were bigger. And actually, I think I should have just used one table on each of the slides. So what we found out that, yeah, like these are the table responses for including the different combination of months, as a part of the input for this, where a yield was actually related to the dormant season precipitation, like as we can see on the upper left side. And then, we established a relationship with the yield for the seasonal precipitation as well, and so on. And, we had the inclusion of, the longitude component as well for the last 4 model inputs. And then, the graph on the left hand side actually shows, the data set for the 3 years when it was pooled together. And then, the relationships were analyzed randomly by distributing the data set into check-in and training data set. And then, we found out, using this whole comparison, that for maize, the longitude component along with the annual precipitation component had minimum RMST and maximum R square with the highest confidence. And similarly for the graph on the left side for the soybean, which includes the pooled data set for the 3 years, like it was very similar that the longitude component actually kind of decreased the confidence, in the data set. However, the RMSD was pretty much consistent throughout. And similarly, like the graph on the right side, it is pretty evident that for the 3 different years, the relationship was not very similar. Where the longitude and the annual component for the precipitation actually helped us have maximum confidence and minimum error for both maize and soybean.
So one of the basic processes, I know that it may not be quite interesting to all of you guys, but when the precipitation comes down on the ground, it's going to store in the soil. But depending on the soil type, you only got like the certain capability to store the water. So all the additional water is going to be drained to the groundwater. And then before the planting, you do have the reservoir of water in the soil to start with. When you plant, and then that water is free for the plants to use. And that's probably part of the reason why the precipitation of the dormant season could have an effect on the because we talk about the early start of the plants, the early vigor of the plants before, that seems to be there can be some associations along those lines. And there are companies that are interested in to make the maximum use of that stored water in the soil profile. so that you can manage less water during the growing season.
Yep. It's all also, like in addition to that, like for the dormant season precipitation, not the only reason. I mean, one of the main reasons. But during those dormant seasons, some of the producers, they tend to plant legumes, which actually help in nitrogen fixation, and then like makes the soil more rich in terms of the nutrients, and then like that could actually like help to affect the yield in the later growing season. And that is very true about the soil thing. Like Nebraska is a very diverse state, so we have a lot of different kind of soils in the whole state, with the clay content ranging from 5% to almost 50-55%. So with the clay increase in the clay content percentage, the water retention capability of the soil also increases. So the soil with 5% clay content would have a lot of infiltration. So like as soon as it rains, all the water would be infiltrated or drained through the runoff. But like this, for the soils with high clay contents, they would have a good water retention capacity, and the water would be sitting in for a longer period of time, which could be used by the plants during the growing season or something. So this is one of the last results. So as a part of the conclusions from this study, we found out that the model performance improved as the monthly precipitation for both maize and soybean were with the maximum inputs, like with the precipitation starting from May all the way till September, performed best for the pool data sets 2000, 2005, and 2010. However, like for these three different years when they were studied separately, the model performance varied. Like for some of the models, as we have noted in the past that, the first 3 months were more important. And then, like for some of the models, the whole maximum input was more important. But, like for the pooled overall, the model with the maximum inputs, performed the best. And in general, maize models perform better than soybean models, which we have been talking about, because maize is more sensitive to water stress. And inclusion of the longitude component into the time step and phase actually improved the performance for both individual and pooled testing years. So and remember that longitude is not the driving factor, it's the precipitation gradient. And the annual precipitation along with longitude as model inputs performed best for the pool data sets. So if we just talk about the precipitation during different months, like annual, dormant, or season, or the combination of all of them, the annual precipitation is one of the like most influential inputs for the yields in the coming years. And like to conclude it all with a brief summary, it would be it will be appropriate to say that with adequate training data, ANFIS can develop useful relationships between yield influencing factors and final grain yield. And these ANFIS models, using time step precipitation along with longitude, can provide reasonable prediction of grain yields. And the performance of these models varied between testing years due to how well the magnitude and distribution of precipitation was accounted for in the training data. So that's what we talked about. These 3 years were very different. So that is one of the reasons the performance in these 3 different years was different from each other. And but overall, when we pooled the whole data set, the conclusions were very straightforward. And like at the last, can say that future research is still needed to reduce this uncertainty and improve model prediction, which was developed as a part of this journal article. And like personally, I feel that if the training data set was larger, we could have definitely had more confidence on what the conclusions for this study were. And at the same time, I also feel that since the work which was carried out as a part of this project was novel, or that was done for the first time for the state of Nebraska, where these rain-fed yield was associated with with the precipitation factor using NFIS. So that is one of the things which makes this journal article unique. But yeah, definitely, like in the coming years, inclusion of more data set would actually make it more valuable and we would have more confidence on this. And yeah, just the references which you've used. Feel free to ask questions.
There is just there's one question from she's asking, instead of longitude, what if you use some other environment? Is that possible? For example, solar radiation.
Solar radiation. So yeah, I know.
Would that be a better option to be included as than longitude?
So the main driving input as a part of this study was precipitation. So I mean, that would have made more sense for this journal article to include precipitation gradient. But yeah, at the same time, solar radiation does have some significant effect. And like the other course which me and Hope are taking, that irrigation management course, I mean, we have been recently talking about it, and I think it could be one of the factors which could be included.
It's also about whether you can get that information or not, right?
Yes, that's very true.
You may be able to inform because there's extended network of weather stations in these days.
Yep.
So you probably can get that pretty accurately.
Yes, that's very
true. A lot of, when you think about designing an experiment, and you have a list of candidate X's you wanted to measure, right? In the hope they will explain why. But the difficulty for a lot of the researcher is you are not even sure if that is a complete list of X or not. You know what I'm saying? Right? So if you wanted to study diabetes, right? So you could look at the different things. But was that a complete list? Or is that even the most influential factor we should look at, right? Because we know very little about a lot of those quantitative information. I mean, quantitative data that the traits that are actually quantitative.
That's true. Yep.
So anyway, so think about it, and then maybe you do know that certain X is very important, but it may take you $1 million to collect X. Then you have to write a proposal to NIH to request for that dollar, or you're screwed and you go with less important X or less expensive. So kind of think about all those things. Those are the things if you later on become a researcher, those are the things you have to deal with. Right? Number one, do you have a good hypothesis? And then number two, if you have a hypothesis, do you have the money to be able to conduct the experiment and collect the data you wanted to, right?
Yep, that's true.
Yeah. Anyways, so any other questions for Jasmine? Yes, Ben.
Please feel free.
Yeah, thanks for the presentation. So, okay, being practical here, I'm wondering if it would be better if it was possible to produce the yield using just the first several months of that crop, because then farmers can plan. I don't know what happens if the grading markets, but is that kind of the goal of this sort of research?
Yep. So let me just try to understand what the question is. You're saying that during by using the precipitation in the first few months, the farmers could actually plan ahead of the growing season and make certain actions so that the yield wouldn't be affected, or to have maximize.
Yeah, or just so they know how much yield they can expect, because that's kind of important, isn't it? That's ahead of time.
That's very true. Using the first few months, during a growing season can actually help a farmer a lot. But we do have the data set for all the preceding years. So definitely your thought is very valuable, and it can actually help the farmer. But we can use the models. I mean, not reliably, but for sure we can use these models to actually predict the yields for the later months based on what we get, what precipitation we get during the early months.
Okay.
Yeah, that's
It's a
possible.
really good point. It's not only just for the farmer. It's a lot of it, the yield forecast is for, like the USDA would like to know at a very large scale, what's the national, they would like to know the prediction of the yield well before the time, so that if there is any problem of yield prediction, they can have enough lead time to do something, right? So that's, relates to the disaster relief, or, maybe that relates to, lost my thought. But you got my point, right? So they all USDA, like the UNESCO, the United Nations, they all want, and they do this all the time, like using large scale remote sensing imagery during the season to be able to see, to make a year forecast 3 months later. And this is that 3 months is really important for like economic indicators, disaster relief, and it's just an insurance as well. You foresee that something is going to happen. Agriculture insurance is one of the big industry that's going to be benefit a lot from this kind of things. So it's precipitation is one of them, but remote sensing is, so to speak, it's happen is much larger scale, even larger scale than this one. Look at the vegetation, look at the greenness, and they will know, oh, maybe this place isn't gonna yield very much because clearly see there is not much vegetation there. There is an infestation of the disease or the pests, things like that. Yeah, good point, very good point. So there's a whole ecosystem around this kind of stuff. Okay.
Okay. Yeah.
Great. So, all right. So there's no more questions. So we will finish this one. And so folks in North Platte. So I would assume that you are satisfied with Jess Raymond's presentation. I should.
Yes, we are.
That's okay, yes, I saw the message, Jared. Thank you very much. So we'll come back together on Thursday. It's a good discussion. I like that. I have more questions, but I guess I don't have to get all my questions. Good.
Thank you.
Mm-hmm.